In this video, I want to give you a quick overview of what we have done so far on our underwater glider project. So this is it right here, and I'm going to go ahead and turn it on. It's going to run through its startup sequence here. And it's going to start calibrating our ballast tank. This is done by pulling the whole mechanism back until it hits it's kind of hard to see here, but there's a limit switch right here. And it's going to keep going until it hits the limit switch. Now that it hits the limit switch, it is now just running a very simple routine where it's just pushing, I guess hypothetically, pushing water out and then pulling it back in. So this is the whole outside. This whole inner container part can actually be pulled out. So let me go ahead and do that. Put this to the side. So now we have our inner mechanism here. I'm going to turn the whole control board back on, and we can go over all the individual parts. So right here we have the ballast tank. This is a 500 cubic centimeter syringe, and all it does, it's very simple, is it just holds water for us to sink and pushes it back out if we want to float. It is controlled by this NEMA 17 stepper motor right here. And yeah, super simple. As we move back, you may notice some changes from some CAD models you may have seen. And this was originally going to be our whole pitch manipulation control area, where we would move this little section, this carriage, back and forth to change our center of mass so we could have control of our pitch. But the submarine actually ended up being very, very heavy, or very, very light, way too light for it to actually be neutrally buoyant. So we had to add these little containers here, which are, you can kind of hear it here, which are filled with lead little pieces, these copper plated lead pellets. And this gives it a lot of weight so that it can actually be neutrally buoyant. And then right here we have our original design, which holds our batteries. And back here we have a buck converter to 5 volts. So obviously we don't have pitch control functionality anymore, but that wasn't absolutely necessary, unlike the buoyancy control. But anyways, let's move back to the control board here. So this is the printed circuit board that we designed for this whole project. And you can see we have our stepper motor connected and our limit switch. And we don't have anything else connected right now, but there is a total dissolved solid sensor that goes back here that reads the just the solute content within the external surroundings. And we have some other, these pins right here will actually connect to an external pressure sensor and an external thermistor. And then back here's some headers for our camera, and we have some just I2C pins, everything like that. We're gonna make a video that goes a lot deeper into this whole board and everything. Of course, we have a stepper motor here. We just left it in here even though it's not going to be used, just to add some more weight and get some air out of the whole submarine. So that's pretty much it. We do have one extra lead weight. Let me get that real quick. So this right here is our final kind of, you can hear the lead. This is the final kind of weight that is used to help the submarine sink. And this just fits around the ballast tank right there. And this whole thing just slides right into our outer shell. So hopefully this overview was super helpful in kind of like giving you a long-awaited update on what we've been working on. I plan to work on a series to go in depth into the CAD, the software, the circuit board, and everything. But hope you guys enjoyed, and let us know if you have any questions. There is a link in the description to all the CAD files, all the code that we've made so far. So be sure to check that out. But other than that, have a great day.